Good evening, everyone. Um, Today, what is the topic I have chosen is doing schema changes in PostgreSQL. So, myself, I am Aakash. I am from Mydbops. I am a database PostgreSQL team's tech lead. And okay, and about Mydbops, we are doing PostgreSQL, and not only PostgreSQL, we are doing managed database and consulting support and services on open source databases like MySQL, MongoDB, PostgreSQL, TiDB, and Cassandra as well. And we do have more than 80 plus database engineers who are expertised in all these databases. And also they have worked on on-premise, cloud, and Kubernetes environments. Also, we do perform meetups, lot of meetups every 3 months. So if you guys are interested, you can also connect with us. We are also doing open source meetups every 3 months. Yeah. Okay, let's jump into the topic. So schema changes, it is very difficult one in every databases because if you are going to perform any schema changes means we need to go for a downtime, because if you are performing alter, that it will need a exclusive table lock. So we can't perform any read and write during the particular time. Okay, so it requires a downtime. If your table size or your data size is very less, it is not a problem. But if your table size is 1 TB means you need to have a lot of downtime. Okay, some organizations won't afford that. So this is a simple tool that is called pg-osc. It is named as PostgreSQL Online Schema Change. It is an open source tool. It is even available in GitHub. We recently explored this tool and it is quite good. And what is the tool means? It is really helpful to do online schema changes. It means it won't lock the table while doing the schema changes. You can perform your schema changes without blocking any operations or not even having any huge downtime for your tables. And it is equivalent to the PTOSC, which is a tool in MySQL by Percona, and PG repack to perform the vacuum full. Here, how many of you have already explored PTOSC and PG repack? Okay, very few number of people are already using that. So if we are already using that, the exact same scenario or a concept being used in PG-OSC as well. Okay, and one more advantage is it is not an extension. So PostgreSQL, if it is an extension means we will be having a problem. We need to add it in extension and we need to reload the database or restart a database. It is just an external tool. You can install it in any one of your VM and you can perform your schema change. There is no restart required on your database as well. Okay, so we already see alter requires lot of lock and downtime. So, and some people, to avoid that, what they will do, they will create a shadow table and do the CDC, like DMS or Debussium kind of thing, and do the schema changes. But it won't suit for everyone. It will be, sometimes it will be a bit complex. So it is good to explore this tool once. Okay, to use this tool, you should have more than database version 9.6, greater than that. And also, your database should have privilege either trigger access or you should be a super user. Then only you can perform the schema changes by using this tool. Okay, it is very simple to install. It is completely written on Ruby code. Okay, so you don't want to install it on a database server. You can install it on some other VMs as well if you are afraid to see some resource usage. So you can use either gem command to perform the installation. And if you don't want to have any dependency issues means you can just go with the Docker. It will be very simple to use that. Okay, so let's see how it is working. First thing it will do is it will create a audit table or else log table. What is the purpose of log table means whenever while doing the schema changes, the insert, update, delete queries hitting your production table or your primary table will be stored on your log table. That is the purpose of this audit table. So once it is created, it will put an exclusive lock on your production table to add a trigger. So purpose of trigger is so that it can capture the insert, update, delete queries, and it can store it in the audit table which is created in the first step. Okay, so it requires access exclusive lock, but it is very, very minimal time, maybe less than a second. Your applications won't feel that. And then it will create a new shadow table which is exact equivalent to your production table. It's only the structure, it won't have any data, it will have only the structure of it. And then next, it will execute the alter which you have given, not on the production table, on your shadow table, which is empty. It won't have any data set. Okay, it will be, then this alter will be executed within milliseconds because it doesn't have any data. So your table is modified as per your requirement. It is having all the columns now. So now it will start to copy the data from your primary table, that is your production table, to the shadow table, which is altered just now. Once the data is completely copied, it will start to create the indexes, which is if anything exists on your production table. And then it will replay the changes which is captured on the audit table, which you have created in the step number 1. It will apply all the insert, update, deletes to your shadow table, so that both your production table and your shadow table will be in sync as per your data. And then at last, what it will do means it will swap both the tables, shadow table and your production table, inside a atomic transaction, so that in case if it fails means you won't lose any data. Okay, if it fails means it will roll back to the older production table. If it is succeeded means you will have your new shadow table as your production table as altered. And then it will analyze the new table because it don't have any new stats. So it will perform analyze to have the updated stats. And then finally, it will drop the older production table. And if you don't want to drop it means you can use an options so that it won't drop your older table. So you can have some data validations if needed. So this is the way pg-osc it's working. Okay, this is the complete flow chart. Okay, what we discussed is given in the form of flow chart. So the same thing is explained here as well. So I'm moving next. So these are the prominent features. As I told, it won't have any lock, but it requires minimal lock at 2 phases. One is during the creation of the triggers, and another time is during the time of the swap of both the tables. So at that time, it requires lock. So it is good to do it in the minimal down or non-production time. Okay, so and no chance of data loss, and also it is rebuilding a table. So it will completely remove your bloat, and then what else? Yeah, and then you can use your custom SQL as well. If you don't want to completely move your data to your shadow table, you can. Let's say you want to move your only 3 months data means you can use that as well. So and a few considerations, definitely that's it. You should have primary key, and it won't support partition table, and it minimal lock, so mind it. And it needs more storage. You need to create your once again your table. So if you are having 1 TB data means you need to have 1 more TB. Okay, and yeah, avoid parallel DDLs. These are a few references, and also we have written a recent blogs which is trending. So you can also refer to that. Yeah, thank you.